So, good evening, everyone. Welcome back to today's session. And am I audible? Please, anyone can just say yes or no. That would be fine. Am I audible?
Yes, sir.
Thank you. Thank you. I would like to wait for 2-3 more minutes for to see that others also join. So I will wait for them. But meanwhile, I'm going to just discuss about these two topics for today. So forces on surface immersed in a fluid and stability of solid bodies in fluid. So these two topics I would like to discuss today. So if anybody of you has any doubt regarding these two topics right now that you would like to discuss first, so I can start with that. Otherwise, that's fine. We'll just directly go to solving some problems. But if you have any doubt regarding these two topics, so you can please ask. So, yes. Okay, so let me wait for 1 more minute. So if nobody else joins, we can start. So, yeah. Okay then. So I guess we can start. So could any one of you please tell me the difference between uh, uh, okay, let's not start like that. Uh, so could anyone of you please tell me about what center of pressure means? Like I guess you have watched week 4's lectures. So could anyone of you please define what center of pressure means? Anyone? Nandik, Kirtana, Priyanka? Like if you know, you can tell. If you don't know, just ask. That's fine. Yeah, please, Priyanka, go ahead.
So it is similar to centered of gravity, but here instead of weight, we are considering the pressure forces acting on the object.
Yeah, thank you, Priyanka. Absolutely right. So, what it basically means that you will just eventually see that I have written a definition. It is the point through which the resultant force due to pressure in a body acts, right? So, if a body is placed, say, a flat plate or any arbitrarily shaped body is placed in a fluid, so it will encounter some forces due to the pressure distribution in the due to the pressure distribution along its surface. So since the pressure distribution is not uniform throughout the fluid, the center of pressure is not equivalent to the center of gravity or center of gravity of the body, right? So you can just refer the below for following diagram, this diagram. So here you can clearly see that this triangle, this force triangle basically represents the pressure distribution in the fluid. Okay, and this is not uniform. Why? Okay, let me just wait. Okay. So why isn't it uniform? Could anyone please explain?
Because of the height.
Yeah, so thank you again. The pressure distribution, if you remember the previous class lectures, lectures of week 3 and the previous sessions, you can remember the equation given by dp by dz equal to minus rho g, or if you just integrate it, you will find that it is minus rho z z some plus some uh, plus some constant, and you will eventually get to know that it is the initial or the initial pressure that we define on the surface. Okay, so this is like that. So here you can clearly see that pressure, I'm sorry, pressure is a function of z, or z basically means in this diagram I would like to show, like z basically means the depth of the where the object is placed from the free surface. If you can remember, this triangle and these two lines represent the free surface, so it is the depth of the object from the free surface, and thus pressure varies with the depth. That's why this variation along the vertical height. Yeah, but if there was a scenario, say the pressure distribution was uniform throughout the depth of the body, say the pressure distribution was uniform, if I say so, say the pressure distribution was uniform, so how do you feel about the position of the center of pressure now compared to the center of gravity of the object? Would it be same, different, or if different, why so?
Sir, if the object is symmetrical, then it will be the same.
Okay, thank you. Like, it's quite interesting, but why do you say symmetrical? Like, if it was unsymmetrical, asymmetrical, what would have happened?
So then it would not coincide its center, no sir. Then it might be below or above or anywhere else.
Okay, like actually I'm not doubting your reply. Actually, I'm quite curious to know this myself. So it's a new thing for me also. Like, I can look into it and then just go about it. But thank you. You're right. If the object is symmetrical, as you say specifically, then if the pressure distribution is uniform, which actually isn't, it's an idealized, or like, what to say, theoretical case that I'm telling, fictional case you can say, that cannot exist. But if it would have been like that, then the center of pressure and the center of buoyancy or the center of gravity of the object would have coincided, given the object is symmetrical, as you have mentioned. But since it is not, since the pressure varies in the vertical direction, literally it increases with the depth, that's why we have a center of pressure slightly below the center of gravity of the object, right? So if you would have attended the lectures by Professor Chakraborty, you would have clearly seen this formula coming through, and the derivation, like if you want to know, you can just refer the lectures again, or the book by Professor Chakraborty, Introduction to Fluid Mechanics. You can refer that book, and you can see that since yp, it is the center of pressure, the position of the center of pressure is equal to yc plus some positive value. Why positive? Because all the quantities are bound to be positive here, because see, ic represents the area moment of inertia. Yeah, right. The A represents the area of the object that has been placed in the fluid, and YC represents the center of gravity of the object, right? So all these three quantities are bound to be positive, no matter how small the value of this fraction becomes, but still this quantity would be positive, and thus YP will always be at a greater depth compared to the center of gravity of the object. Okay, so I guess this is a very simple concept, but it's important for you to remember. So that's all. Okay, then we just recapitulate or look upon the forces on curved surfaces. So okay, so like I'll just explain a bit and then just go through it as quick as possible. So this, imagine this, there is a curved surface placed on the placed in a fluid, okay, at certain depth. So this is the curved surface. I've drawn it by this black line. Yeah, and here you can clearly see the forces acting on the surface, in this curved surface. So there are various ways to evaluate it. Okay, I guess Professor Chakraborty also mentioned about the integration, like if you know the function of this curve, you can solve it, find out forces by integration, by taking elemental area. Okay, but for as an engineering point of view, or as engineers, we would like to take the simpler approach, or like the approach that is deemed to be much simpler and equivalently accurate. So here we take the concept of projections. So here you can see that if you recall it from the lectures, the horizontal force that acts in this curved surface is equal to the horizontal force that would act in the vertical projection due to this curved surface. Okay, and as you can see here, the vertical projection would be this area. If I just mark it, yeah, its vertical projection will be this area. Okay, and if you recall again, and if you recall again, uh, sorry, the horizontal force would be the horizontal force would be equal to the force that acts in this in the vertical projection of this curved surface area. Okay, and the vertical force, the net vertical force, would be equal to the weight of the object, right? If I'm not wrong. So yeah. Okay, so yeah, so I guess again these are clear. So yeah, so let's now directly go to is anything like, okay, so is there any doubt regarding these concepts, in this first concept at least, the forces acting in a acting on a surface immersed in a fluid? So is that clear? Nandik, Priyanka, Kirtana. Oh, yes, thank you, Nandik. Thank you again. So, yeah. Okay. So, yeah. So, now we look into the stability of floating and submerged bodies. Okay. Yeah. So, I just wanted to ask you the difference between floating and submerged bodies. So, could any one of you please explain me the difference between a floating and a submerged body? Nandik, why don't you? Okay. Priyanka, yeah, you can go. Yeah, you can go ahead, please. Yeah, sorry.
Hello, sir.
Yes.
Or should I wait, sir?
No, that's fine. You can go ahead. That only I told. No? You can go ahead, please.
Sir, in submerged body, the object is entirely inside the water body.
Yeah.
Whereas in floating, it is half inside or half, or depending upon the, some portion will be inside, some portion will be outside.
Okay. Thank you again. Like again, I'm curious to know, what determines the height. Like if you just think about it, you solve some problems, I guess. What determines the depth up to which the body is being submerged in the case of floating bodies? Like what is the determining factor in those cases? If you could just recall. Like say there's a body A and there's a body B, and you can say that, say the body B is more submerged. Okay, Nandik, I can just complete the question. Compared to body A, the body B is submerged to a greater height compared to body A. Body B is submerged to a greater depth compared to body A. So what insight do you get from this? Like, what can you say about body A and body B if they're submerged in the same fluid? If they are floating on the same fluid and body B is submerged to a greater depth compared to body A, then what can you say about body A and body B?
So the one which is submerged, like the one which has more height, it is its density is more compared to the fluid density.
Yeah. See, yeah, you're absolutely right. It's related to density, but its density cannot be greater than density of fluid, right? If it is, then it will not float. You can say its density is greater than the body compared to which it has been submerged. Submerged, I mean the sense, not completely submerged, but immersed in the fluid to a greater depth. So, do you get it? Okay.
Yes, sir.
Okay, thank you. Nandik, and okay, Nandik, you mentioned about, let me check again. You mentioned a center of buoyancy. Like, do you have any doubt, or you wanted to say that this is what drives the depth of the immersion in the case of floating bodies? Ah, hmm. Uh, I guess not directly. Center of buoyancy it is actually dependent on the density of the body. Like, if you think so, like if the body is denser, it would get submerged within the fluid to a greater depth. Okay, and then the center of buoyancy would just be determined by the submerged, the height of the submerged part divided by half. Okay, if it is symmetrical body, as Priyanka correctly mentions, if it is a symmetrical body, then it would just be the half of the submerged part. Say, I will just make it clear because maybe I am not being able to explain it in a better way. Say this is a free surface of the liquid, and the body is submerged, say, to this depth. Okay, say, and this is the height, depth of immersion within the fluid. Then, as a conventional approach, the center of buoyancy is just being given by, say, if it's a, the center of buoyancy is just given by h by 2, if I'm not wrong, right? The center of buoyancy, right? The center of gravity would be obviously the, if it is h, the height of the body is h, say, then a center of, sorry again, the center of gravity would be at h by 2, and the center of buoyancy is half. Yeah, it will be here. So let me, this center of gravity, then it is CB. So is that clear, Nandik? Okay, thank you. Yeah, so since all of you have nicely clarified me that my doubt regarding floating and submerged bodies, so let us first discuss about, say, completely submerged bodies. Okay, so yeah, for stability for completely submerged bodies. Yeah. Okay. Yeah. So could any one of you please tell me, like, if you recall from the lectures, what is the determining factor or determining parameters that decide the stability of such bodies? Like, is the question clear? Like, what are the two or whatever the number of parameters are there, that determines the stability of submerged bodies? Height, weight, pressure. Yeah, Priyanka, go ahead. Yes, please.
Uh, the stability, it will depend on the center of buoyancy and center of gravity.
Okay. So anyone else? Like, do you have any other opinions regarding it? Please. Like, it's not be a monologue or dialogue between the one student and the, what to say, me. So, like, I want every one of you to contribute your own opinions. If it's the same, then just say it is the same. Or if you feel like there may be some other factors that can determine the stability, then just please mention. I would also like to know. Nandik, why don't you go ahead? Like, what do you think? Okay, you have written something. Let me see. Okay, certain metals and multiple. Okay, yeah. I guess you misinterpreted my question. You are relating the concept to some other case that I am going to discuss, but I am discussing about submerged bodies. If you remember, submerged body basically means a body that is being completely submerged within the fluid. Okay, so in that case, I don't think metacenter comes into picture, but yeah, I guess you got it now. So yeah. Okay, so yeah, Priyanka, as she mentioned, she's absolutely correct. It is the center of buoyancy and the center of gravity that determines the stability of completely submerged bodies. Okay, so I would just like to draw one picture, and I would not repeat everything that has been discussed by Professor Chakraborty. I will just draw one picture and ask you about the locations of these points and how the locations of these points determine the stability. Okay, that would be better and I guess more efficient. So I guess this was the exact diagram Professor Chakraborty has used. So okay, again see, it is completely submerged, so there is no point of meta center here. Say this is the center of buoyancy. Now I will use different colors so it is more clear. Yeah. So this is the center of buoyancy. Say I give it the notation B, and this is the center of gravity. Again, sorry, this should be what? Wait, this is center of gravity. Okay, so I think I drew it correctly. Yeah. So yeah, say I want two cases right now. For now, two cases: stable and unstable. Okay. Yeah. So now I would like to make the class more interactive. I would like ask anyone other than Priyanka and Nandik to like let me know the answer for this like discussion, I could say. Like say I have given you the position of the center of buoyancy and the center of gravity of an object completely immersed in a fluid. So what is the case, what is the scenario for a stable equilibrium in this case? What should be the respective positions of the center of gravity and the center of buoyancy for a body to be in stable equilibrium? Manikandan and Kirtana. So you two can try, or if you don't know, just please ask and I can just explain. So it would be good. I'll wait for some time. Like, I can understand. Okay, Kirtana, thank you. Thank you so much for at least telling me that you didn't get it. Okay, I will just explain again, okay? So, yeah, that's fine. So, Priyanka and Nandik, you are free to go if you have your answers. Like, could you tell the respective positions of the center of buoyancy and center of gravity for a stable equilibrium? Okay, Nandik, please go ahead.
So, center of buoyancy will be more close to the open surface and center of gravity will be below that.
Okay, thank you so much, you're absolutely correct. So for the body to be in stable equilibrium, the center of buoyancy should be above G. Okay, so yeah, Kirshana, let me draw you a diagram to make you understand. So please let me know if I was successful in making you understand this concept. So yeah, but also I again suggest you to revisit the lectures. That will be of your greatest help. But still, from my side, I will try to let you know, make you understand from my side. So let's just see. Okay. So again. Okay, let's before that, again, since you both of you, like Nandik has correctly mentioned about stable equilibrium, and again I guess it will be just the vice versa for unstable equilibrium. That's fine. But could any one of you, or any one of you from the class, yeah, four of you, please explain me the stable, what do you mean by stable equilibrium and unstable equilibrium in the case of complete submerged bodies or floating or submerged bodies in general? Like, what do you mean by stable and unstable equilibrium? Could you please explain me? Like, in one sentence, two sentences at max. Simple concept. Yeah, Nandi, please go ahead.
So for stable equilibrium,
Yeah.
if we change the position or tilt the body,
Yeah.
it will have a restoring couple and it will come back to its original position. But in case of unstable, if we just move the body a little bit, it has a destroying couple. It will not allow it to come to the place it was before.
Okay. Thank you, Nandi. Thank you for your explanation. So, any one of you, like from the rest of the class, do you agree to his explanation? Like Kirtana, I understand you don't get you didn't know the concept. That's fine. But Manikandan and Priyanka, do you agree with his opinion regarding stability? Yes, Manikandan, please.
Yes, sir, I can understand.
Okay.
Yeah, I agree with that.
Okay.
And I want to know this concept. It is B should be above G, stable is correct?
Yes, yes. Nandik mentioned it.
That means
Yeah.
G less than B. That means B greater than G, correct?
Yeah, yeah.
Okay, sir. Okay, thank you. This is my doubt. This was a question from assignment, so only I asked this question.
Oh, no problem. That's fine. That's fine. If like accidentally I helped you in your assignment, that's fine. But
Sir?
Yeah, Priyanka, please.
So for stable equilibrium, B should be less than G, right?
No. Actually, it should be above G. So what Nandik mentioned is correct. But why do you think so?
No, sir, I'm telling the distance. Like in the assignment, there was a similar question.
Okay.
Like for stable equilibrium,
Yeah.
the height from the free surface, B should be above or below G, something like that.
Height from the free surface, like I guess if the free surface is mentioned, it will be basically depth and not height, I guess, right? It will be
Yes, sir, sorry, sir. Depth, sir. So OB and OG, so OG should be greater than OB for stable equilibrium.
Yeah, that's understandable, right?
No, sir, but in the assignment solution, sir, it was given opposite, sir.
For stable,
Yes,
for
I
stable.
was also wrong.
Okay, so like I guess then you should don't follow the given solutions. Think logically. So if you logically think that your answer supports your what to say your queries, then I don't think you should go ahead with the assignment solution. Then you can write mail to the NPTEL regarding it. Okay, like I'm just trying to clarify. Okay, what you are trying to say. Okay, let me just draw it so that everyone can understand. So you're giving that there is O here, right? This is O, right? You can unmute yourself. Just discuss with me. That's fine.
Yes, sir. In the question, it was mentioned that B denotes the distance of the center of buoyancy from free surface.
Okay.
And G denotes the distance of center of gravity from free surface.
Okay.
So, which among the following conditions ensure stable equilibrium? And another question was for unstable equilibrium.
So this should be stable according to your question, and this should be unstable. Yeah, I guess this should be the correct answer. Is it, or is it just the opposite?
In the assignment solution, they have given opposite, sir. What like opposite of what you mentioned.
Okay. Okay. Let me go through it. Maybe I will ask the other TS also regarding it. You can also attend the other TS sessions so that they can clarify maybe. But in the if you're mentioning the, if I'm understanding the question in the correct way that we have mentioned and what they have asked, this should be correct. Okay. If you're measuring from free surface, this should be correct. But I don't know what they have written. So yeah, please. I will discuss with them. Okay.
We mentioned it in the discussion forum also, sir.
Okay. I guess they will get back to you. I may also see. So that's fine. That's fine. No problem. Don't worry.
Okay, sir. Thank you.
Your
Sir.
concepts will be clear. Okay. Maybe some answers are wrong sometimes. Your concepts will be clear. That's all.
Okay, sir.
Okay. Manikanna, do you have any more doubt? Like you have still raised your hand. Like there's no doubt. Then you can just lower your hand, that's fine. Do you have any doubt, Manikandan?
No, sir.
Oh, okay, no problem. Okay, no problem. That's fine. Okay, so Kirtana, I'm drawing this diagram for you so you can understand in a better way. So yeah, let's see. Let's all of us see. Maybe we get some conclusion. Like, so that's fine. Okay. So this is the surface of the body. Sorry, surface of free surface. So okay, let me do it a bit far. Okay. So this is the surface of the fluid, and we denote the free surface. And again, we draw the same body. And just tilt it, like Nandik said, just tilt it from its slightly from its equilibrium position. Okay, just tilt it slightly from its equilibrium position to see how the body acts given the positions of the center of buoyancy and the center of gravity are predetermined or already given. So yeah, this is the axis, central axis of the body, and say what was it? This is the center of buoyancy. This is the center of gravity. Okay. First case. Say this is the first case, and then again I should draw a vertical line to let us know about the angular displacement that we have created to see the check the stability. Okay, so yeah, and say since the body is tilted in this direction, okay, in this direction, so it basically means we have applied a force in a clockwise direction. Okay, we have applied a force in a clockwise direction that has caused the body to have a slight rotation in around the clockwise direction. So is that clear, Kirtana? Just say yes or no, unmute yourself, that would be fine. Okay, thank you, that's fine. So here, Kirtana, again I'm asking you only, say this is the center of buoyancy of the object and this is the center of gravity of the object. Okay, so in which direction do you feel the center of buoyancy of the object will act? Up, down, left, right, or in any angle? Like, what do you suggest it would act like? Left. Oh, no, actually. So see, center of the buoyant force would always try to act vertically upwards. Okay, resisting the if the body is like being placed in a fluid, the fluid will have some repelling force that would try to keep the body up. Okay, it is only at that point that when the volume of the fluid displaced by the body is greater than its weight, then it would sink. Okay, so the buoyant force always act vertically upwards, remember that. Okay, so the buoyant force will act, okay, thank you. So the buoyant force will act vertically upward, and again this is a very basic concept that the weight of the object would act vertically downwards. Okay, so if this is the case, like it's better if I zoom it. Yeah, if it is the case, then if we consider a perpendicular distance between these two forces, say this line, is that clear? Yeah, then you can see that there is a couple that acts couple. Okay, the couple are basically two forces acting in the opposite direction respective with having a perpendicular distance between them. Okay, so the couple would act in a counterclockwise direction. Like, is that clear? It will act in a counterclockwise direction, right? Okay, so you can see that initially we have applied a angular displacement in a clockwise direction that has caused the body to have a angular displacement of theta degree. So this was our initial direction of angular displacement, say given by this one. And what we have done is, because of the position of the center of buoyancy and center of gravity, there is a restoring couple in the opposite direction, in the counterclockwise direction. Say if this is clockwise, this is counterclockwise. As Nandik has correctly mentioned, this is the restoring couple that causes the body to get back to its original position. Given that their initial displacement was very less, so very less, or like up to a certain limit, this is the restoring couple that acts in a body in a counterclockwise direction to make the body reach its initial position. And that's why the body is said to be stable for this case. Is that clear, Krishna? Okay, thank you. That's fine. So I guess now it's clear. So unstable will be just the opposite. B should be below G. Okay, I guess that's clear. So do you have any doubt regarding this concept for submerged bodies, at least stability of submerged bodies? Okay, I guess it is clear. So yeah, so let's now discuss briefly about submerged bodies, floating bodies, stability of floating bodies. Okay. So yeah, so again, like the previous case, or like what are the two parameters? I'm sorry. Now, what are the parameters that determine the stability of floating bodies? Like previously it was submerged bodies. So now what determines stability of floating bodies?
Metacentric height.
Yeah, same. That's same. Thank you. Yeah, that's absolutely correct. So you have rightly mentioned it is the metacenter or metacentric height. It's fine. Okay. So yeah. So any one of you, like, could you please briefly explain what do you mean by metacenter or metacentric height?
So
Yeah.
metacentric height is the distance between the centroid of gravity to metacenter.
Okay, then what is metacenter?
Metacenter is if we draw a line, perpendicular line through center of buoyancy, then the point of intersection is called as metacenter.
Intersection with what?
Intersection with the axis of the center of the gravity.
Okay, thank you. Like, I cannot find any fault in your definition. It's absolutely correct. So yeah, I would like to again draw a picture. So it is clear for everybody. So say this is the free surface of the liquid, and say that the body is initially the body is placed like this. No, I guess I should draw both the diagrams so it is clearer. So yeah, so this is the free surface of the body. The body is initially being placed like this. Okay, this is the axis of the central axis of the body. Okay, and say we give some names to the points, that is points or the vertical line that is along the free surface of the liquid, the vertical line of the body along the free surface of the fluid. So that will be a much clearer understanding. Say this is A and B, and this is the initial shape of the body, and say we give a slight displacement again like the previous case, in this direction, okay, like in the clockwise direction. We give a slight force in the at point B, say it is B double dash. Yeah, at point B double dash we give a slight we give a slight force which causes, okay, please wait, yeah, which causes the body to have a slight tilt, slight angular displacement in the clockwise direction. Okay, then the body would assume the shape, assume this position. Okay, so yeah, let me draw the central axis again. So like this. Okay, this would be, okay, A dash and B dash. Say the positions have changed. So yeah, so here we say G denotes the center of gravity of the body. Okay, and since, yeah, in this case, since the body is if for this given body, say if G is here, and since the the complete body is not immersed in the body, and only partially it is being immersed, so the center of buoyancy will lie slightly below than G. Okay, I should say B1, so there's no confusion. Okay, say B1 is the center of buoyancy of the object. Okay, so if this is G, okay, and now where do you suppose, say it was in B1 here, okay, it is B1, sorry again, it is B1. So now because of this tilt, say again, I have to be very cautious regarding my drawing. It should not, yeah, so it is being displayed by some angle theta again. Okay, so because of this displacement or slight perturbation that we have caused in the body by applying a force at this point, where do you think the center of buoyancy would be? Like, would it be at B1, or would it shift in certain direction, or which direction do you think it would go? Like, could anyone please explain? What do you presume it would be? It will be. Yes, Priyanka, please go ahead.
Sir, it will not be at B1. It will shift towards
Where?
right.
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 You mean here?
Yes, sir.
Okay. So say we say that the center of buoyancy has shifted at this, say, point B1 dash. Okay. So yeah, thank you. But for saying that, Priyanka, I'm asking you again only. So why do you think it happens? Why do you think the center of buoyancy shifts when we give some perturbation to the initial position of the body?
Sir, because when we are tilting the body, the volume which is displaced, it is more towards the right.
Yeah, thank you. You're right. You're absolutely right. Yes, thank you. Since as she has correctly mentioned, since the volume of the submerged body has, like, in some sense changed, right? It has changed its orientation respect to the symmetry of the body. The center of buoyancy will shift accordingly to resist this displacement and create an equivalent upward force to balance this displacement. Okay, I guess it's clear. Like, since we applied an additional force that has caused the body's orientation within the fluid, and you can basically see that it has now become the, the volume of fluid that has been displaced has become asymmetric when compared to the central axis of the body. Okay, the initial central axis of the body. Since it has changed, the center of buoyancy will shift accordingly to balance this change in the proportion of the volume of fluid displaced. I guess that's clear, or like I guess I have made it clear. Like, do you have any doubt regarding this? Okay, thanks Nandik. I guess I tried like I made a good effort to make you understand. That's fine. Okay. So yeah. So since B1 is now the new center of buoyancy for this displaced body. So as one of you, Priyanka, has correctly mentioned, now we just what to do? We extend this, extend a vertical line from the center of buoyancy of the body. Okay. Yeah. I'll zoom in. We extend a vertical line from the center. Yeah. Here. See. It intersects here. So this denotes the metacenter of the body. Okay, and as you this is the metacenter, and this distance GM is the metacentric height. Is that clear? Okay, so yeah. Now since we know the concept of metacenter and how like it is being determined, and I guess like most of you would have done such experiments in your fluid mechanics lab, so I guess you know the concept clearly. So again, like the previous case, could anyone of you please tell me about the stable and unstable, the condition for stable and unstable equilibrium for floating bodies, and given that metacenter is the determining parameter. So could anyone of, or metacentric height? Yeah, Manikandan, please go ahead.
Sir, when the immersed body is tilted, we can find the metacentric point. But while it is not tilted, means can we find the metacentric point?
Okay, so yeah, that's a very good question. Let me think about it. See, metacentric height is basically what to say, a way to denote the direction or the direction of the buoyant force that acts in the along the central axis of the body. Okay, to know the point at which the buoyant force acts along the central axis of the body. Okay, and since the body is not tilted in this case, like this one, I guess, case 1, here we already know along which direction or which point the buoyant force acts exactly, right? We exactly know that this is the point at which the buoyant force acts, that is along the axis of the central axis of the body itself. Okay, but since the body has been displaced in case 2, sorry, in case 2, and hence since the position of the center buoyancy has shifted, now we need to determine along which point in the center, along the center axis, the center of the buoyant force acts, and that's why we need to know the position of the metacenter in the case of this slightly perturbed or displaced body. Okay, Like otherwise, if it is not tilted, like that, then we know only that it acts along the center axis of body, along the axis where the center of gravity acts. There's no point of finding this meta center in that case. Is that clear? Yeah.
Yeah, it is clear.
Okay. Thank you, Manikandan. Thank you. Okay, again, yeah. So let's get back to our initial discussion. Like, could any one of you please tell me about the criteria for stability and instability in the case of floating bodies? Yeah. Yes, Priyanka, please go ahead.
Hello, sir.
Yeah, please go ahead. Yeah.
So for stable bodies, M should be above G, and for unstable bodies, it should be below G.
Okay. Yeah, so any one of you, do you agree with her opinion, or like if yes, then it's fine. If no, like do you have any other opinions regarding it? Okay, I guess everyone agrees to with Priyanka, and yes, because she is right. Like, see, I would explain in this diagram itself again. Okay, right? It is clear because similar to the previous case of completely submerged bodies, here we can clearly see that since we know that at M at the meta center itself, it is a point where the buoyant force acts. Okay, so this would have a component of the buoyant force along this direction. Say it is too messy, so I would again just draw slightly outside. Okay, so it is clear. So say this is the central axis of the body. This is the center of it. This was the initial center of buoyant force. This is the center of gravity, and this is the meta center. Okay, and since we know it is along the meta center the new buoyant force acts. So the buoyant force will have components along this direction, and the gravity, as we know, the gravity would act in the vertically downward direction. So this is weight and this is FB. And since our initial displacement was in the clockwise direction, as it is mentioned here, this one, you can clearly see that if we have again like the previous case, if we have a vertical distance between these 2 points, extend these two forces, you can clearly see there is a restoring couple, or not restoring right now, like cannot say like that. You can see the orientation of this couple is in the counterclockwise direction, and this is clockwise direction. And since this is against the initial disturbance that we have given to the body, this restores the displacement or the tilt of the body to its initial position, and thus making the body stable, and thus being named stable, a case of stable equilibrium. And as you can clearly, and again similarly the vice versa, it's if M is below G, say if M is below G, again I can draw here itself, this is the center of buoyancy, initial center of buoyancy, not now, and say this is the center of gravity, and say this is the meta center. Okay, and again we have given the same initial displacement here. If this is the case, you can see that the center of gravity now acts along this direction, the buoyant force acts along this direction, and again if we draw a perpendicular line between these two forces, you can see this couple now acts in the clockwise direction. And since the initial displacement was in the clockwise direction itself, and this couple due to now the respective positions of the metacenter and the center of gravity is again in the clockwise direction, we can observe that this couple would cause the body to tilt more or rotate, have a higher angular displacement because of this additional couple that is being acting because of the respective positions of M and G. Okay, and thus the body will move further away from its initial equilibrium position, and thus the name unstable equilibrium. Okay, and thus we can say the body is unstable. Okay, so I guess it is clear. So is it clear, the stability criteria for floating bodies and submerged bodies?
Yes, sir.
Thank you,
Yes, sir.
Manikandan. Yeah.
I can understand. And is it right? In case one, the body will move to a stable condition, right?
Yeah.
And there, M is above G.
Yeah.
It means stable, right?
Yes.
Yes. But in the unstable condition, it will move to down.
Yeah.
Yes, sir.
Yes,
Yes.
because
Okay,
of this
thank you, sir.
rotation. See, there is an additional couple that makes the body rotate further away from its initial position. That's why.
Okay, sir. Okay, sir. But these cases are not possible in the condition submerged bodies.
Yeah, not
Right.
possible. Yeah, not possible because there the center of buoyancy remains the same.
Okay, okay, sir. Okay, okay. Thank you.
Okay. Here the center of buoyancy changes because the volume of fluid that is being displaced by the body changes. That's why center of buoyancy changes. But since in the case of completely submerged bodies, the volume of fluid that is being displaced by the body remains the same no matter what its orientation is. That's why the center of buoyancy remains the same no matter what its orientation is. Okay, so that's why we need to take into account the concept of metacenter in the case of floating bodies. So I guess that's all. I guess we had a very good comprehensive discussion regarding this concept. So that's very good. So yeah. Again, okay. As for your knowledge, okay, just for your knowledge, I would like to say something more regarding this stable and unstable equilibrium. Okay, so if any one of you in your future try to study advanced fluid mechanics, okay, like if you're doing your masters or PhD, so you might encounter a subject named like advanced fluid mechanics. Okay, so in there you may encounter some other chapters regarding stability. Okay, stability, hydrodynamic stability, like that. In that case also the concept of stable and unstable remains the same. It's a very fundamental concept, not only being applied that is not only applied in the case of floating bodies but also in a in the fundamental flow level of how the flow becomes stable or unstable. Say if you may know regarding the concept of laminar and turbulent flows, right? So, and you also know that the flow transitions from laminar to turbulent, and how does the transition occurs? That's a very important concept, and this transition is being it is driven by the concept of stability. Say if for a given conditions, if the flow becomes continuously unstable, the flow would transition from laminar to turbulent. Okay, but for the same flow, if for a given flow condition the flow is stable, like even if like we apply some perturbations to the flow field, if the flow has a stable equilibrium, if the flow is stable, then the flow wouldn't transition to turbulent flow. So this is like the basic understanding of stability and unstability, just for a knowledge. So if the body stable and unstable, okay, unstable. So for an initial perturbation, Do anyone of you know what perturbation means? Okay, that's fine. So right now you can just take it as disturbance, a small disturbance. That would be actually a very good synonym or understanding for this word, and you get to know about this more when you read about turbulent flow fields. That's fine. So yeah, small disturbance is given. In the case of stable bodies, the flow tends to return to its initial stable state. Okay, and just the vice versa. For the case of unstable flows, the flow tends to move away from its initial stable state. Okay, so this is a very basic definition or understanding of stable and unstable equilibrium. So you'll just get to know more about this in the later parts of, not this course at least. If you take advanced fluid mechanics course in the later part of your studies, you get to know about this. So that's clear. That's really about it. So I guess this was all I wanted to discuss in this class. So yeah, so we can directly go to the question and answers. We can discuss some questions to get a clear understanding of these concepts. So yeah, please go through this first question. I guess this will be very helpful to understand the concepts. So you can go through this first question, and meanwhile, just go through the question and try to tell me the approach that we have used to solve this question. Okay, I'll wait for some time. Oh, I'm sorry again. Yeah. Please. I'm sorry, I had to leave my desk for some time. I'm sorry again. So did anyone here figure out how to solve this, or you're trying? Uh, okay, let me read the question once. Uh, Gate ABC given in figure 1, given in the below figure, is is 1 meter square and is hinged at B. It will open automatically when the water level H becomes high enough. Determine the lowest height H for which the gate will open. Neglect the atmospheric pressure. Okay. So yeah, it's a very actually it's very good conceptual question that helps you to understand the topic that we've discussed today, and obviously that has been discussed very clearly and extensively by Professor Chakraborty. So it's a very good conceptual question. So first of all, I'm not questioning your understanding level, but have like did you understand the question clearly? Like, did you understand the gist of the question? Yes or no would do. Like if no, I would explain. If yes, then I would ask you to explain me. Then what did you understand? So yeah, please. Priyanka, Nandik, Manikandan, Vishnu. You understood the question? Okay, yeah. Priyanka, please unmute yourself and like tell us like how would you approach this question? First, tell us what you mean by the question, and then please tell us how would you approach the question.
Um, Based on the height of the water, there will be some force acting on the gate.
Okay. Let me follow with you. Yeah, you will say based on the height of the water, there will be some force on this gate. Yeah. Then
Okay, that force will cause will cause a moment about the hinged point.
okay. So where do you think the forces will act?
Uh, f- uh, for the gate to rotate, it should act along AB, on AB.
Okay. So okay, I guess you are going in the right direction. So for the gate to rotate, it should act on AB. Why not BC?
Because there is some obstruction which is shown in the picture.
Yeah, you're absolutely correct. Yeah, because of this obstruction, even if a force acts at BC, it will stop the gate from opening. So for the gate to open, the force should act along AB. That's what you're telling, right?
Yes, sir.
Yeah. So when would that happen? Like what you're trying to find. Yeah, let everyone know like what you're trying to actually find. You're trying to find H, but how you're approaching to find H in this case.
I thought that first I'll calculate the force acting on the gate.
Okay.
Then I'll consider that I want it to cause anti-clockwise movement.
Okay.
So that should be greater than 0. So then I will get H through that.
Okay. So I think your approach is in the right direction. Yeah. So you can please go ahead with it. Meanwhile, like others also, please try. I will wait. Say what is time now? It is 8:12. Okay. So I'll wait for 3 more minutes. 5 more minutes. Let's say 5 more minutes. And then I'll stop to share my screen right now. Then I will try to solve myself, and let's return up after 5 minutes. Okay. Like the screen will be blank for some time because I will be solving myself. So you can take the screenshot of the question, or I guess take the diagram of the question and try to solve individually. So would that be fine or like that's problematic for you all? Okay, let's leave it. Let's leave it. No, that's fine. Nandik. Yeah, let's leave it. Yeah, I'll let the screen be open and let the screen be like this. Then I will solve after all of you have given your answers. Okay, that would be better. So yeah, please try. I'll wait for 5 minutes. That's all. Okay, 1 more minute. So I'll just wait till 8:18 and then just see. So okay, I guess so. That's all I can. That's all I can wait, so that we can have enough time for other problems. So yeah. So did any one of you reach to an answer? Priyanka, Nandik, Manikandan, Vishnu. Like Vishnu joined late. That's fine. But three of you, like, did you any one of you reach your any answer?
I didn't get the answer, sir. I got stuck.
Oh no, that's fine, because I guess 5 minutes is really less for such question. That's fine, but just for the sake of completing the problems, I am giving limited time. But that's fine. It's very good that at least you are trying. Nandik, what do you think? Nandik, sir stuck. Oh, that's fine, no problem. Manikandan, did you try? I knew you try, but did you also get stuck or you got an answer? Okay, so let's let's approach it in a similar way like what Priyanka said, but a slightly different say a slightly different parameter that I will try to find to oh sorry, yeah, I would work upon a similar concept but slightly different parameter to get the answer. Okay, so I guess for this class only I'll solve only this question because this is the one that is a bit difficult and quite interesting. So yeah, I'll just discuss this question for today's class. Okay, let me draw a diagram again. Okay, bear with me, it will take some time, but yes, good things take time, so you can wait for a while. Meanwhile, do any one of you are very clear with the concept of inequalities? Like, say there is an equation. Oh yes, thank you, Nandik. Then I will need your help. Okay, help me out. I am a bit doubtful regarding my concept, so I will need your help. Okay, Nandik, thank you. Help me out. Okay. Thank you. So this is B, this is A, this is C, there is again a stop here, so yeah, stop here, and this is 60 centimeters, this is 40 centimeter, this is H. Okay, yeah. So as Priyanka mentioned in her while explaining her approach, she told that the force should act at AB. Okay, and here she is absolutely correct, because if the force acts at AC, the gate will try to rotate in the clockwise direction, which would not be possible because there is a block here. Okay, there is a block here that will stop the gate from rotating. So it's not desirable since the gate won't open and we will not be able to release the additional or extra water that we want to release. Say to mitigate the extra water or mitigate the flooding scenario that has been done in the uphill of the dams. Say this is the case, just an example, okay? This is not desirable. What we want is that the force would act along AB so that there is a counterclockwise rotation that will open the gate and release the additional water, okay? But here, since if we go about through forces, now the force, now see there are two forces that we need to encounter to determine the couple, right? And then it becomes difficult because there is a same fluid, this is a same plate, that's the catch, this is the same plate that is being hinged at B. So the two forces makes the problem quite complicated. But we know one concept of center of pressure, if any one of you recalls center of pressure, right? And we know that it is that point along which the resultant force of pressure due to the fluid column acts, right, in a submerged body. So considering that this plate, this rotating, the plate that has the ability to rotate, that is being hinged at A, is a submerged body in this fluid with height h, we can assume that the force, say again I should name it, say FAB should act along this point, say this is YAB, where YAB is the center of pressure, right? Since this is the center of pressure, the force AB would act at the point YAB. But we need to know what is the height that would cause the force FAB in this plate to be at YAB instead of being anywhere at BC, say YBC. Are you getting it? That we don't want the center of pressure to be at anywhere at this range, at BC. We want our center of pressure to be anywhere from A to B. Is that clear? Please let me know, yes or no. It is very important concept. Yes, Priyanka, are you clear? Yes, thank you. Manikandan?
Sir, can you repeat, sir?
Yeah, sure, no problem. That's why I asked. See, you know the concept of center of pressure, right? Yes, it is at that point through which the pressure force due to the column of fluid acts in a submerged body, right? So if the center of pressure lies anywhere along BC, right? Along BC. Okay, if you don't mind, I would just like to, thank you, Manikandan. Yeah, so if the center of pressure because of this column of fluid, if the center of pressure is anywhere along BC, say it is at this point, even if it is this point, this would have a tendency to rotate the plate in the clockwise direction, which we don't want, because even if it rotates, it won't open because of this block. It won't open, it will get stuck here and the gate will remain closed. But if the force acts anywhere in the range of AB, in the length AB, say even if the force acts, I can zoom it, anywhere, say even if it acts here, if AB dash, say at AB dash, even if it acts here, even though the moment will be very less, the gate would require a huge effort to open, but still it would have a resultant moment or along the counterclockwise direction, which would cause the gate to open. So we want our center of pressure to be at any point above this 40 centimeter mark, or at that point anywhere at between A to B. Okay, because
Yes, sir.
because if it is anywhere here, then the resultant force will act along here, then it doesn't operate the gate at all. So we want it to be in the range of AB, right? So yeah, so keeping that concept in mind, I guess if you recall the formula for center of pressure YP, then it was equal to YC plus IC by AYC, if I'm not wrong. Okay, if I'm wrong, just please correct me. Okay, then what would be the YC for this plate, the plate AC? Please, any one of you, could you please tell what will be the center of pressure, center of gravity for the plate AC in terms of H and the given dimensions? Yeah, Priyanka, Manikandan, anyone, please, no problem. Yeah, Manikandan, go ahead. Oh, Priyanka, go ahead. Priyanka, go ahead. You're telling, so that's fine. Priyanka, go ahead.
So H plus 0.5.
H plus 0.5. Yeah, because the gate's dimension height is 1 meter, right? So it is 0.5. Yeah, you are right. Thank you. So yeah, Manikandan, since you have raised your head, you can help me to tell what would be IC, the area moment of inertia for the plate.
Breadth into height cube is IC.
Okay.
But here breadth is
If you
1 meter.
Yeah, it is 1 meter
Yes,
square.
Yes,
Yeah.
1 meter square. Height will be
Same.
Height will be 50.5 centimeters.
No.
0.5 meter.
It is for the entire plate. I am telling about the entire plate.
Entire plate. Okay, one for this one.
Yeah, that is one basically, but to be what to say, accurate, you can write like that, but it doesn't matter at all. But still, just for your ease of understanding, and divided by 12, if you could remember, I guess it is divided by 12. BH cube by 12. Like, if this is the dimension, and if this is B, this is H, and if you want to find your area moment of inertia along xx, your Ixx is BH cube by 12. If I'm not wrong, please, if I'm wrong, then just please let me know.
Yeah, we know, sir.
Yeah, so this is right? So since in this case B and H are equal, it will become 1 to the power 4 by 12. Okay. Yeah. So and A would be again, I guess, 1 square. It is a square multiplied by again YC is 0.5 plus H. Okay. And yeah, and now what we want is that this height, this center of pressure plus 1 by 12 into 0.5 plus H should be less than, if we measure from the free surface, okay, should be less than what should be less than? Any one of you, please.
H.
Okay. Any one of you has another opinions?
No, it
Nandik.
is H only.
H. Nandik, what do you think?
Sir, actually I think it should be greater than H.
Okay, I'll get to it, but please ignore the inequality because I'm very poor in it, so forgive me for the signs. But regarding the right hand side, at least, what should it be? Greater than, less than H? Or is it H or is it something else? The right hand side. Measuring from the free surface. Nandik, please tell your opinion. Do you agree with H or it should be something else? 1 minute. Okay, no problem. Oh, sorry. Okay, I guess we are short of. Okay, no problem. That's fine. Hey, but help me out with inequality. Okay, you said you will help me out with inequality signs, so I need your help. It should be actually h plus 0.6. Why? Because I told right in the range of AB. So where does the point B lies? H plus 0.6, right? Even if the force acts here, it will cause a anti-clockwise moment that will cause the gate to open. And even if it acts here, it will cause the gate to open, right? So we need H to be the center of pressure to lie between this range, right? Is that clear? Why I chose H plus 0.6? Yeah, thank you, Nandi. Yes, Priyanka.
Sir, uh, in the question they asked, what is the lowest height h now, sir? So in that case, we should consider, we should consider a case when it acts at A. Is it like that?
No, no, no.
If the highest h, then we should consider h plus 0.6. I thought like that. Is it correct approach or wrong?
No, no. Actually, the thing is, you can consider like that, but your equations will change. Now you are finding something at some other parameter to find it. But since I am telling, I am trying to find the center of pressure, because I want the center of pressure to be anywhere between A to B. So I cannot choose my deciding height to be at here, right? There is no point of choosing it here. I want my center pressure to be slightly above this. That's why I'm choosing H plus 0.6. I want my center pressure to be slightly lower than H plus 0.6. That's why this inequality sign.
Okay, sir. Okay, sir. Thank you, sir.
Measured from the free surface, I want my center pressure to be slightly below H plus 0.6. And here also, if we just, no matter what your approach is, the unknown parameter is here is H. Eventually, we will turn out an equation in terms of H, and we will have to find the value of H. That's all. No matter what parameters do you choose on your right and left hand side, it doesn't affect at all. So, is that clear? Or
Yes, sir. Thank you, sir.
yeah, sure, no problem. So this is H plus 0.6. Okay. So right, left hand side I initially resolved. Meanwhile, Nandik was trying to solve out the problem. So it would be H square plus 0.2 into 0.5. So it will be H, I guess, plus 0.25 plus 1 by 12. If it goes there, then it will become H plus 0.6, H plus 0.5. Okay, then this becomes H square plus H plus 0.25 plus 1 by 12 is less than or equal to H square plus 1.1 H plus 0.3, if I am not wrong. So I can cut out the H squares, then if I take, it will be 0.25 plus 1 by 12 minus 0.3 less than equal to 1.1 minus 1 H. So this turns out to be around, let me do it, minus 0.3 plus 1 by 12. So it turns out to be 0.0333 like that, and less than 0.1 H. Yeah, so Nandik, now I need your help here. Okay, so would the inequality sign change if I take 0.1 here? Any one of you? I don't, that's why I'm asking, I was curious, that's all. No sir, yeah, thank you. So it basically becomes H should be greater than equal to 0. Yeah, thank you Nandik, thank you so much. 33 meter. So H should be at least greater than 0.33 meter. Okay, so I guess this was one of the options, I guess, here. So this is the answer. So is that clear, everyone? Thank you, Vishnu. Priyanka, is that clear?
Yes, sir.
Thank you. Manikandan?
Yes, sir. Clear, sir.
Thank you. Thank you so much. Okay. So this was very involving problem. That's why I took so much time. So okay, have I missed a question? Okay, I'm sorry. Okay, I guess I missed the diagram for this question. So just let me check it. Okay. I guess I missed the diagram for the question. Okay, so I will draw the diagram. I'm really sorry. I missed the diagram for question number 2 while making the question. So I'm really sorry. So consider the following diagram, okay? So this is your, let me draw it by black. This is a curved surface area, and this is the free surface of the liquid again. So yeah, and this is hinged at this point, okay, hinged at this point, and there is a pressure force that, sorry, there's a force that acts in this direction. Okay, say this is B, this is point B, this is point C, and the height depth of the water is 2 meter. Okay, I'm extremely sorry I missed the diagram and the question completely and just have the sub questions, so I'm really sorry. So this is water, okay, yeah. So this is hinged at C, okay, this curved surface is hinged at C. So given this question, what is the horizontal component of the hydrostatic force at gate BC? I guess I briefly discussed about curved surfaces submerged in fluid and how the forces act regarding the projections and the weight of the body. I guess how the weight of the body and the project determines the vertical forces, and the projection, the force acting in the projection of the curved surface determines the horizontal component of the hydrostatic force. So keeping in mind those concepts, for anyone who please tell me what would be the answer for the first question. Question number 2, the horizontal component of hydrostatic force acting along gate BC.
So width of the gate?
Oh, yeah, sorry, let me check that also. Width of the gate is 3 meter. Yeah, thank you for pointing out. The width of the gate is 3 meter. And it is a quarter semicircle, okay? To be clear, like maybe my drawing is very wrong, very bad, but it's a quarter semicircle. Quarter circle, what I'm saying? Quarter circle, sorry, quarter circle. 1/4 of a circle, to be precise, yeah. So 1/4 of a circle, depth is 3 meter, hinged at point C. What is the horizontal component of the hydrostatic force acting at gate BC?
Sir, option D.
60 kilonewton. Yeah, that can be one of the answers. So I don't know. That others also contribute. Others, yes, we are very short in time today. We are very short in time, so we need to be quick. So I know it is a involving questions. These are involving questions, but if you know the concept, it's very simple. I can't find. No problem, sir. No problem, Manikandan. That's fine. Yeah, Nandik, did you chat? Did you write in chat? Oh, no. Okay. Priyanka says it's 60 kilonewton. It's her answer. Right. Any one of you? Okay. So I guess since we are short of time, I'll just go about it. You are right, Priyanka. The horizontal component of force is 60 kilonewton. Could you please tell how did you find it?
So projection of BC.
Okay, so it would be, say I write rho g. Yeah, again one more hint. I take g as 10 meter per second square. If you take 9.81, it will approximately be equal to that. So that's also fine, but for ease of calculation, take it 10. It's very wrong actually. Yeah, thank you, Nandik. I don't know why they asked us to take this. It is what it is. Say,
Take 10, it will be exactly 60.
yeah, that only at all. For ease of calculation, it will come out to it exactly 60. Yeah. So rho is, since it's water, so density is 1000, g is 10. Oh, sorry, Manikandan, I didn't get. What did you say? Like,
Sir, I can't understand your words because you are going very fluently. Just could you please quite slow your fluency?
oh, sure. Maybe
Quite
I was.
slow.
Yeah, I'm sorry. Maybe I'm going fast. I'm really sorry. I'll try to speak slowly. Okay. So yeah, thank you, Manikandan, for pointing it out. So the horizontal component of the hydrostatic force Fh is found by this formula, like as discussed by Professor Chakraborty in his lectures and as briefly discussed by me. So here A would be the projection, the vertical projection of the curve BC. Okay. So since it is being mentioned that the depth of this gate, the depth of this curved gate is 3 meters, so it would be basically the area would be 3 into 2, this height, right? It will be this height. So, and HC would be, I guess, the center of gravity. So AC would be turn out to be the half of 2, that is 1 meter. So if you just evaluate it, it will turn out to be 60,000 newtons or 60 kilonewton, as rightly pointed out by both Nandik and Priyanka. So it is 60 kilonewton. So I guess it was clearer, Manikandan. Let's.
Yes, sir.
Okay. Thank you. So yeah, and now let's go to the third question. Similarly, since you already found out the horizontal component, please tell me what will be the vertical component of this hydrostatic force.
So second option, 94.5 kilometer.
Okay. This is Priyanka's opinion, answer. So all of you guys, do you agree with it? Okay, so like, yeah, this answer is also correct. And if you all recall, the vertical component of the hydrostatic force is basically the weight of the fluid that is confined in the curved surface, confined within the curved surface. So since this is a quarter circle, we know that we can undertake it, consider it to be the quarter of a cylinder of length L. So since the volume of a cylinder and FV would be basically given by rho V G, right? So rho is again 1000, and if we consider the volume of the cylinder to be like pi r square L, then the 1/4 of, to find the volume of the fluid in the quarter of this cylinder, it will basically be divided by 4. Okay, and then G again you take as 10 for simplicity again. So if you substitute the values, four, and it's again 3, again divided by 4.
Sir, here 10 is acceleration due to gravity.
Yeah, I told, right? For simplification, they've asked in the question to take us like this. That's why. If not mentioned, then just take G equal to 9.81. That is more correct. But since they have mentioned to take this, that's why I am taking this. Okay.
Okay, sir. Thank you.
Okay. So if you evaluate it, it will come out to be 94.25 kilonewton. So that's correct again. So since we are very short in time today, so let's proceed to the next question. So yeah, this is again interesting and again involving. I guess this should be, we can take this to be the last question for today, but okay. So yeah, what is the horizontal force P required to hold the gate stationary and neglect again, okay, neglect the weight of the gate? So I will just show you a diagram. So they asked us to find out this force P that is required to hold the gate in its position. Okay. Now since you already know that there is a horizontal force that acts, say there is an FH, then again there is FV because of the weight of the fluid. So given that these forces act, you know at least the direction of these forces, then you just need to tell me what would be the value of this force P that would be required to hold the gate in its position, and it is hinged at C. Okay.
So is it 60?
Okay, let us look into that. Okay, you tell it is 60. So yeah, this is again a very interesting question, and maybe I also didn't like quite rigorously solve it, so it would be very helpful if you could tell us how did you approach the problem. Okay, help us, every one of us, to let us know how did you solve it. Okay, please help me.
So since we already calculated the horizontal and vertical force,
Okay, let me write it. FH is 60 kilonewton and FV is 94.25. Okay. Yeah, we know that. Then
we can get the resultant force, and it should act through the along like at the point at the free surface.
uh,
Or equilibrium.
could you tell me where? Here.
No, sir. At the center of the semicircle.
Here.
Yes, the resultant force should act there.
Okay. So I guess it should be along this direction. You're saying, right?
Yes, sir.
Okay. Then how did you find out? Tell me the calculations.
Then calculating the moment about point C.
Okay.
And weight is to be neglected as per the question.
Yeah. So no. FR should be then act in the opposite direction if I'm not wrong, right? Then only to resist, or what are you trying to say? Should it be like this or like this?
Sir, the top one, sir.
That only. Yeah. Okay. So you're telling it would be Fr into 2 would be equal to P into 2.
Sir, FR into 2.
Yeah, so please.
I resolved FR into FH and FV.
What? Please tell me.
I resolved FR as FH and FV.
Oh, yeah.
So
Yeah. Then?
FH into 2
Yeah.
plus 0 into FV is equal to 2P.
Why this? Okay. Nice. Then your P comes out to be 60 kilonewton. Right. So thank you again. This is the correct option. So thank you for everyone to help everyone to know the right answer. So yeah, this is correct. So is everyone clear? I guess Priyanka helped us very nicely to get the concepts clear regarding this question, because I also didn't rigorously solve it. So thank you for helping me out. Yeah. Okay. Since we have 7 more minutes, I guess we can take a little bit regarding the next question. And this is again a very conceptual question. And so if you know the concept, it is very easy. I guess this is question number 5, I guess. 5, yeah. So what is the vertical force on the semicircular panel AB in the figure given below? Vertical force on a semicircular panel AB. And the width into the paper is B. Okay. So yeah. We need to find FV. Please check the options and tell me what would be the right answer. Oh, Manikandan, you have raised your hand. Did you already solve it?
Sir, I did not raise my hand.
Oh, no, it's actually showing. That's fine, no problem. Yeah. That's fine, no problem. I will lower it. Yeah, that's fine. Okay, please go ahead with it. We have some 5 more minutes, so you could solve this quickly. We can look at the next question also.
So B.
B. Okay. Priyanka says it's B. So anyone else? Do you have any other answers or same answer? Then also that will also work. Okay. Since you're short of time, I'm rushing it. I'm really sorry for that. Okay, Priyanka, please could you please tell me how did you find B? Yeah. It is right because so please tell us how did you find it out?
Sir, like the vertical force should be the half of the like that AB.
Half of AB? What is half of AB?
No, sir. Sorry. Means the vertical force should be the weight of the water acting on the surface. So I divided that AB plate into 2 parts.
Okay.
So on the first part, like I put a point between AB as on semicircle as C.
Okay.
So the vertical force acting on AC will be downwards.
Okay.
Then I projected it up AC to get the vertical force.
Okay. What is it?
Then the volume of the water, sir, for AC.
This region, right? or the other one?
The top one, sir.
This one, right?
Yes, sir.
How did you find out? Just tell us.
For AC and then similar to BC also I did the vertical projection. It
Yeah.
will get cancelled.
Okay, so you found out like this, right? This
Yes,
one.
so the finally I will get that. So whatever the vertical force, it should be the volume occupied by that AB gate, half of that semicircular panel.
Yeah, you're absolutely right. Your approach is absolutely correct. But to simplify it for others, like if you recall in the class, I guess professor also mentioned regarding these kinds of surfaces, which do not hold the fluid within them, but in an external surface to them. Like this surface not holding fluid within its confinement, but external to it, like on its other surface, on its exterior surface, other than its interior surface, like the problem that we have previously solved, right? Since here also it is the curve is holding the fluid in its internal surface, right? But in this case it is holding the fluid outer to its on its other side, not in its internal side. Okay, so in these cases here also we take the vertical forces that acts in a body to be, like we assume that there is a fluid within this curved surface, and find the weight of that imaginary fluid to find the vertical component of the force, if I'm not wrong. Like this is what exactly how sir mentioned in the lectures. So, and what we have done is also correct. From that approach also we get the same answer, but to simplify that we just assume that there is a fluid within this region and find the weight of the fluid within this confinement. So it will basically be, again, since it's half of a cylinder, it would be pi by oh, let me clarify it. So half of pi by 4 d square. Again, what was the b? I guess b, this is the volume, and again rho and g are always there, so it will turn out to be pi by 8 d square b rho g, and I guess it is absolutely exactly what it is. So that's clear, I guess. Is that clear? Nandik, Priyanka.
Yeah, clear, sir.
Thank you, Manikandan. Thank you, Nandik and Priyanka. That's clear?
Yes, sir.
Okay. Yeah, what you have done is also correct, but just in a simpler manner, how Sir mentioned, I'm just portrayed it in my way. Okay. So I think we are out of time for today's class. But if you guys agree, I can carry on, but I think that would be wrong. What you could do is you can just take the screenshot of this question. Okay, just take the screenshot if you're using a screen, or if you're in a laptop, there also you can take screenshot, or just what to say, take a photo of this from your mobile phone or anything. Just take the photo of this question. And since many of you are repeatedly attending my sessions, so I'm very happy for that and thankful for that. What you could do is you could find the answer for this question, and right before the start of next session we could discuss the answer for this question. Is that fine?
Fine, sir.
Thank you.
Fine.
Yeah, thank you, Manikandan. Thank you, Nandik. Thank you, Priyanka, and thank you, Vishnu. So this is basically the concept of, again, stability of submerged bodies, floating bodies. Yeah, you can take that concept in mind and find out what would the stability criteria for this given geometry, okay, of this given shape. Like, given the condition that it is being submerged vertically in a fluid, what would the stability criteria? So that's what we basically asked. So yeah, I guess we're out of time, and thank you again all of you for joining today's session. I once again insist you to regularly attend Professor Chakraborty's lectures, because they are the most beautiful or most useful resource that we'll ever get to understand fluid mechanics, basic fluid mechanics in the best way possible. And also attend the other TS or the other sessions, other live sessions for the same topics to get a better understanding, because I might have not interpreted correctly many concepts. Maybe I pour in that, or so you could get a clear understanding by the live sessions of other TAs. Okay, so please do attend them also. So thank you again. Okay, so yeah, so thank you all. I will just end the session for today. So yeah,
Thank you.
Thank you.
thank you everyone, thank you. Okay, yeah.